Alright, it's time for another math easy solution. Turn to discuss another video on summations. Basically look at the proof for the sum of n positive integers but all to the power of 4, or what I mean by that is this: if you have sum of I as I initially is 1 up to infinity, or n, or whatever this is, I to the power of 4 equals 1 to the power of 4 plus 2 to the power of 4 plus 3 all the way to n to the power of 4, and a formula for that, well, which I'll prove now, is basically n times n plus 1 times 6n cubed plus 9n squared plus 1 plus n minus 1. So it's pretty big, all divided by 30. Basically, I'm doing this video because some random guy asked me for help on his math question, which involved proving this. So I'm like, might as well do a video on it. Now, before I get to the proof, first I want to go over the proof for telescoping sum. If you see my earlier proofs on I to the power of 3, I to the power of 2, and basically just positive integers I to the power of 1. Basically, I always use the telescoping sum, and it's basically going a bit higher power I plus 1 minus I to the power of 5, or telescoping, or collapsing, because you'll see this in a bit. I've written part of this right here just to save time in this video. So basically, if you were, this just means, so this I plus 1, if I is 1, this is going to be 2 minus 1 to the power of 5. So 2 to the power of 5 minus 1 to the power of 5. And then the next one, if I is 2, you'll have 2 plus 1, that's 3 to the power of 5. So that's this one right here. Then minus the I, which is 2. So as you can see, there's a higher one minus a lower one, higher minus lower. And it's going up from here, 1, 2, 3, etc., all the way to n. And as you can see, as you can see the pattern, if I were to highlight the bracket this and this. So as you can see, every time to the right there's negative 2 to the 5. This cancels with this. That's why it's called a collapsing sum. So this cancels with this. So now if we have a bracket in this one, this 3 cancels with this one, and then etc. You're going to have something here cancel with this 4. So everything cancels, and then when you go to near the end, this is the second last one. So n and n minus 1, because if it's n minus 1 plus 1, you'll just have an n here. So then this would cancel with this one. This is n plus 1, and then this is just n, because if you just put in I is equal to n, yeah, then you have the plus 1 this one. So this one cancels with this, and then this one would have canceled with another one somewhere right before it, like that. So we'll just cancel that. So all we're left with is this, and that's this n plus 1 at power 5 minus 1 right here. So now, yeah, now basically the next step is to simplify this one here, and then you'll see that we'll be able to cancel this I to the power of 5. So basically we'll be able to cancel anything to the power of 5. I'll show that in a bit. But now, so basically you need to calculate or find or expand this one out. You could either use a calculator or an online calculator, or I will just use this method that I showed, similar method I showed in my earlier video on expanding polynomials, or basically expanding, factoring, etc. So this just means n plus 1 times n plus 1 times n plus 1, and then times n plus 1. And then we have this minus 1 here, but we'll only look at this one right here. So there's 5 of these. So the way I would do it is using this method. We'll look at these two first, and we'll write it down like this. This is just n. This is 1, n, 1. So n plus 1, n plus 1. Then you just multiply these like this. But yeah, so make sure to watch a proof video of this in the video link below as well. So then we're going to have an n here, and this will be an n. So 1 times n is n, and then here 1 times 1 is 1. And then we add the diagonals. These are the same powers. Then this equals 2, or let's put an arrow here. This will equal to n squared plus 2n. So we just add up everything plus 1. And the diagonals are the same, so we just add them up like 2n. So this is, we'll have this one right here. And now this is multiplied by these ones right here. Yeah, now I could basically put these back in there, n plus 1, yeah, times n plus 1 times n plus 1. So now I just put these 3 over here, and now we'll do the same method with these two parts right here, and actually, and then we know these ones right here, this one is equal to just n plus 2, 2n plus 1 here. Yeah, so then instead of using these next two, we'll use this one after we find this one using the same method. So we got n squared, I'll put a line like this, n squared, 2n, and then plus 1, and then just an n and a 1. This is going to be n cubed, n times 2n, that's 2n squared, n times 1 is n, then this one here will have an n squared, 2n, so the diagonal 1. And again, we add up the diagonals. It's going to be equal to, or just put an arrow, so we'll put n cubed plus, this is 2n squared plus n squared, that's 3n squared. And now this diagonals, this is 3n, and then plus 1 right here. So then this is all going to be multiplied by, well, n plus 1, or just this one right here, because we've already calculated that n plus 1 times n plus 1. So that's just times this by n squared plus 2n plus 1. And now we could multiply this the exact same way as this method right here. Okay, so now I just quickly put them up top here. So now we multiply this. It's going to be n to the 4. So I forgot the 2 here, so that means this is n5. Yeah, there has to be a 5 somewhere. So we'll have n to the power of 5, and now n squared times this one. This is 3n4. So the powers add up using power rules. And then it's 3n squared, 3n cubed. And then this one right here, this is 2n4. Remember, the diagonals are always the same power. And then 3n squared, 2n, that's 6n cubed. There's diagonal again. And then 2n, this is 6n squared. And then this one right here, we'll add these one, n cubed. This is going to be the same thing, n squared. The two diagonals are squared, and then we'll have a 3n. So now we add these all up, and this will equal to, actually it's too big for there, I'll just put them over here. We'll have n5, yeah, n5 plus, this is 5n to the power of 4. And then these diagonals right here, yeah, this is 6, 3, and 1, that adds up to 10. So 10 and 3, and then this one right over here. Actually, yeah, something's wrong. Actually, yeah, we forgot to multiply this one in here. So this is n squared. This is, yeah, I forgot the 1 here. So 2n and then 1. So this is n cubed. And so now, yeah, we add these up. 3, 6, and 1. That's another 10 plus 10n squared. This one's on 5. And this should have a little pattern here. This is 5n. And then plus 1 right here. So there's a 5, 10, 10, 5. So this is how it should be. And then a 1 here. And 1 coefficient in this one. So yeah, this is how it looks. And then again, we have the minus 1 right here. So then this collapsing sum, so yeah, I just wrote that down. So the telescoping or collapsing sum equals to this. As you see, the 1's gone because we had a minus 1 in the earlier form. So then it just cancels with this one. So we have this one right here. So now we could use this in our proof. Proof for the I to the power 4. Because remember, this value right here, this equals to basically n plus 1 to the power of 5. And then there's an I plus 1 to the power of 5. So we can just plug in the same formula inside of here. So yeah, if we place this power in here, or this expanded form of this power, we get over here in the telescoping sum. So then this one up to this section all the way up to here, this is just I plus 1 to the power of 5. So now we have an i's, and then we minus I5, and now these cancel right here. So then this one cancels with this right here, so we could just make an x on it. Yeah, so basically we cancel that out. So now we're only dealing with the highest powers to the power of 4, so we gotta find or solve for this one. But now we could use our previous formulas for this I3, this I squared right here, because we could break this apart into basically, yes, basically we're using summation rules. We could basically write these all down in summations themselves, so 5i4, etc., all the way here. And I'm gonna call this summation S4, this one S3, just to make it easier to write, because it's just too hard to keep writing this. S2, this one right here S1, this could be S0, this is just 1 right here, so S0, and when you're adding up basically 1 plus 1 plus 1 plus 1 all the way to n, that's just going to be, well, this is going to be n. So that's just going to be n, because 1 plus 1 is 2, if the n is 2, 1 plus 1 plus 1 is 3, if n is 3, etc. So whatever n is, that's going to be their answer. And now, yeah, and now I'm going to use the formulas that I proved in my earlier videos. So this one is for S1, this is just S2 right here. So these are formulas we get. This is S2, and then S3 right here. So we could just plug these in and then solve for our S4, or this I to the power of 4 right here. 3 Yeah, so here I've written basically this part right here, but using the new notation, the S4, S3, S2, S1, and then the N right here. And now if I were to write these formulas inside, I would get 5 times, well, S4. So yeah, if I put those formulas inside, we get these ones, this 5S4 plus 10 plus this stuff plus this, and all the way to N right here. So now, and then this equals, we know the right side, and then from the right side, it's just equals to this part right here. And so here I've written the right side here. And now to the first thing, so basically what we have to do is simplify using a lot of algebra. So it's just going to be tedious work. But to simplify it, we'll first divide by 5 on everything, because there's a lot of factors of 5. So if we divide by 5, this would cancel. This would be a 2. This would be a 2. And then basically this would be a this would cancel. Then we have a divided by 5 on this part right here, a divided by 5 here. This would cancel. This would be a 2. This would be a 2, and this would cancel. So then we're basically going to be left with, I'll write this down right here. And so here I've rewritten this with just simplify this, get rid of all these crosses of the 5, etc. So we have this part right here. And now to simplify, well, to do the algebra, we need to expand or FOIL out all of these, this function and this function and this function. I'll do these separately. I'll write this one down right here. So we get this part right here, 2 times n plus 1 divided by 2 all squared. Simplify this, we'll get a 2, multiply the n inside, n squared plus n. Then we got to square that. Then there's going to be a 4 right here because this is squared. So then this will be 1 over 2, and then using FOIL method, this is just going to be n squared times n, that's n cubed, and then we basically will have n squared times, times, I made a mistake here, this is n to the power of 4, so n squared by itself, and then n squared times n, that's 3, n cubed, but then we do the same thing again, so we'll have a 2n cubed. I'm trying to skip a step here, but you should be able to do this. And then plus the last one, n squared. This is just n times n using FOIL method. So now if we rewrite this, divide every single one out, so we'll have n4 divided by 2 plus n3 plus n squared divided by 2. So we have this part. So now let's do this one right here. So expand this out, so we get a 1 over 3. Yeah, so we get this part right here, 1 over 3 n times n plus 1 times 2n plus 1. So simplify this, 1 over 3. Multiply this n inside, we'll get n squared plus n times by 2n plus 1. So now we FOIL method this out, multiply this by this, and this by this. We get 1 over 3. This is going to be now 2n cubed plus this part right here. This is, so then n squared times that. Now we have an n times 2n squared and plus n, last part. And these two just add up to 3n squared. So now we divide by the 3 out, we'll get 2 over 3 n cubed plus the 3's will cancel, just n squared, and then plus n divided by 3. And then the last one is this part right here. Let's put an arrow there. So we'll get n times n plus 1. This is just divided by 2. There's no number in front. So this would just be n squared plus n divided by 2, and this equals to n squared over 2 plus n over 2. So we get this part right here. So now the next step is basically just to do algebra and just subtract this side, subtract the left side from the right side right here. So I'll do that all in one step. So basically S4 will equal to, so here I've written it down. Basically S4, I made it by itself on the left side, equals to whatever the right side was, and then minus now the 3 stuff we simplified. So the first part, this this part right here, this n4 divided by 2. So but we're subtracting now from the right side. So we get put negatives everywhere. This is n cubed, n squared plus 2. This is n squared plus 2, etc. And now this part. So this when we simplify this one here, so we subtract this 2 over 3 n cubed, etc. all the way to this part right here. And then we also subtracted this n squared minus 2 minus n over 2. And also the last part, just make sure you don't make a mistake, is this one n over 5. That's this part right here, so we have to include that. So now we basically add or subtract the like terms. So we look at all the powers of 5. There's only one, so that's going to be n5 over 5. All the powers of 4. So we'll just write n to the power of 4. This is going to be now 1. Just you could add up the coefficients. Really fast way of adding, as it's going to be the only thing there. So there's nothing else. Now plus now n to the 3. See what's there. There's a 2. There's a 1. So just add up the coefficients. Then there's a 2 over 3 right here. And that's all for this one. Now if we look at the n squared plus n squared, the coefficients here, 2 minus this 1 over 2 minus this part right here, 1 over 2. And now the last one, the n, we'll have 1 right here. So 1 minus this part, 1 over 3, minus this 1 over 2, 1 over 2, and then minus this 1 over 5 right here. So we get these part right here. So we can simplify this one here. This 1 minus 1 or 1/2, that's going to be a half. So we'll have n to the power of 5. 5 is going to be plus n4 divided by 2. So that's going to be a half. Now this part right here, this one we have to, yeah, well this one's going to be a 1, so we'll have it a 1 minus 2 over 3. Then use common denominator, multiply top and bottom by 3. So 3 over 3 minus 2 over 3, that's just going to be 1 over 3, or n3 over 3. And then when we look at the n squared, we'll have this 2 minus 2 halves. Well, 2 halves just become, actually I made a mistake. This is 2 halves, but we forgot to include this term right here. So there's another minus 1, so let's put it here, minus 1. So 2 minus 1 is 1, then minus 2 halves, that's going to be, well, minus 1 again, so that's going to be a 0. So this just becomes 0, so we can ignore that n squared. And now when we look at this part right here, well, this one we actually, to do this, you need the common denominator, and this one's actually going to be 30, because there's going to be 2, 5, and 3. That's the only thing that's going to be, the lowest common denominator is going to be 30. So we multiply top and bottom by 30, and this one, so 30, put a 30 here. So this one's going to multiply 30. This one's going to be 1 over 3. So then you have to multiply by this by 3. By 10 on both top and bottom, so it's going to be minus 10. This one has multiplied by 15, so minus 15. This one multiplied by 6, so 6 here. And now this is 10 minus 15 is 25, minus 6 is 31. So this is going to be equal to, well, 30 minus 31, as is going to be negative 1 over 30. So then our final answer is going to be 1 over, oh, there's an n here, so n over 30. So this is the final answer right here, except that initial proof up top is a bit different. Yeah, so this one right here is a bit different than ours, but if you expand this out, you'll get the exact same answer right here. But now I'll try right now to work backwards, or just to get back to the original formula. Yeah, so the first step is to multiply top and bottom by to get the common denominator. In this case, it's going to be 30, because we're just going to have a 3. Well, yeah, well, 30. So it's going to be 30. So we're going to be equal to, I'll just put a divided by 30 everywhere. So that this one, to get a 30, we multiply this by 6. So 6 on top and bottom. So we'll have 6 and 5, because 6 times 5 is 30. This one's going to be 15. So plus 15 and 4. This is going to be a 10 plus 10 and 3. And this one is just going to be a 1. So it's going to be minus an n right here. Yeah, actually, yeah, so this is basically as far as I know how to get to this one here, but we can double check that this is the exact same formula. Yes, if I copy and paste that right here, and if I just were to expand this out, we'll get n times, this is going to be, yeah, so basically if you FOIL this out, the same method I showed above, you'll multiply this out right here, 6 n to the 5, this is n squared n cubed, this n cubed n, this is going to be 6 and 4, and now this part right here, n2, this is 9 and 4, and then 9 and 2, this is n9 and 3, and then right here we'll have just n cubed, and then n squared, and then this part's negative n squared, and then negative n. Add these all up, we will get basically 6 and 5, And now so to add up the diagonals is going to be, well, 15 and 4. As you can see, these are similar to what we have right here. Yeah, this is the exact same thing. We have 6 and 5, 15 and 4. And again, I'm just foiling out this top part right here. So there's obviously going to be divided by 30 in this answer. So basically 15 and 4. So now this part right here, this is going to be plus 10 and 3. And yeah, once again, that's the same thing right there. And then minus this one right here. Actually, this part cancels out. N squared and negative n squared cancel out. And then we're just left with negative n. So negative n right here. And all divided by 30 is this part right here. So basically, this is the exact same thing we have. So this proves that we got the right answer. Well, anyways, that's all for today. Hopefully you enjoyed this video. It's a bit long, but it's just a lot of algebra. So it's pretty straightforward as long as you understand the telescoping or collapsing sum, and just use a lot of algebra to move around all these terms and solve from them. You might make a mistake, but just be careful if you do this in a test or whatnot, if they would give you this one. Well, anyways, that's all for today. Remember, you can always download these exact notes in the Dropbox link below, and thanks for watching, and stay tuned for another Math